confused by all those statistical terms and formulas? Don't worry. This tutorial series is designed to make everything simple and easy to understand. We'll break down distributions, the concepts of mean, median, and mode, and measures of dispersion with clear, practical examples. So get ready, and let's start learning step by step in just a few minutes. Let's suppose we randomly selected some healthy subjects and measured their blood glucose levels. We would get a collection of readings, kind of like what I've shown on the screen here. There'd be a few people with low numbers, like 85, and there'd be a couple of people with higher numbers, like there are some 112s in here. And then there'd be a lot of people in the middle. And if we plotted the blood glucose level on the x-axis, and the number of subjects that had each level of blood glucose on the y-axis, we would get something that looks like this. There'd be some number in the middle here that was very common. A lot of people had this number in the middle, and as you went above it this way or below it that way, you would find less and less subjects had each measurement until you got down to some number that nobody had on either side. And it turns out, a lot of things in nature have a distribution like this. We call this a normal or a Gaussian distribution, and it's clustered around some central number, and then it tapers out evenly as you go away from that central number, either higher or lower, and many things are like this. For example, if we looked at height of people, we could find a distribution like this. If we looked at weight, if we looked at the number of days people stay in the hospital for treatment for pneumonia, we might find a cluster around some central number of days, and then tapering out as you go above or below that. So many things in nature have this distribution, and therefore we spend a lot of time talking about how to characterize it in statistics. So the first characterization of that normal distribution I want to talk about are measures of central tendency. So you noticed that the curve looked something like this, and it tended to collect around a central number, and we call that a central tendency. This is the center of a normal distribution. And there are three ways to characterize that central tendency of the distribution. The first is the mean, which is the average of all the numbers. The second is the median, which is the middle number of the data set when they're all lined up in order. And the third is the mode. It's the most commonly found number, and we'll talk about all three of these now, so just to keep this simple, instead of all those blood glucose levels, let's imagine that we had 6 recordings of systolic blood pressure, and they were 90, 80, 80, 100, 110, and 120. Well, the mean would be the sum of all 6 of those numbers divided by 6. So that's very easy to get. You've probably done this many times when you average things out, and that would be 96.7, this data set. The mode is the number that comes up most frequently, and in this data set, there are 2 examples of the number 80. So the mode would be 80. The median is the middle of the data set, and the way we determine the median is a little bit different depending on whether we have an odd number or even number of data elements. If we have an odd number of data elements, like suppose we just had 3, 80, 90, and 110, then the middle number is the median, and that would be 90. If we have an even number of data elements, let's suppose we had 80, 90, 110, and 120, then the median is going to be halfway between the middle 2 numbers, so it's going to be 100. So just remember that the median is a little bit tricky to measure. It's different from the other 2, and it depends on whether there's an odd or even number of data elements. And very importantly, you have to put all the data in order to find the median. First thing you have to do is start with the lowest number and work your way up to the highest number. Once you have them laid out, you can figure out the median value. So let's get back to this chart of blood glucose levels on the x-axis and the number of subjects with each recording on the y-axis. And let's figure out where the mean, median, and mode are for this distribution. Now I haven't given you any numbers down here on the x-axis or on the y, but we can still figure out where the mean, median, and mode are just based on the shape. So the mode is very simple. It's always the highest point. Remember, the mode is the number that occurs most commonly, and we have number of subjects over here on the y-axis. So that's the number of times that recording occurs. So whatever this blood glucose level is the most common, and that's why it's the highest point on the curve. If the data are evenly distributed, like in this example here, where there's an even number of measurements on the left side and the right side of the mode, then the mean and median are equal to the mode. So anytime you see a nice, normal, even distribution like this, the mean, median, and mode are always at the top, right in the middle. Now, data sets aren't always evenly distributed. Sometimes they are what we call skewed. And data sets can have either a positive or negative skew, and the way to keep straight what's a negative skew and what's a positive is to look for the tail. So the tail of this data set is pointing in this direction, and that's towards the negative numbers over here. So when the tail points that way, it's called negatively skewed. And the way you figure out the mode, median, and mean in a negatively skewed data set is as follows. First of all, remember that the mode is always the highest point, so that's the easiest thing to find next. Remember that the mean is always furthest away from the mode towards the tail, and then the median occurs in the middle. And these rules will still hold up when the data are positively skewed. So here's an example of a positively skewed data set, and you can see that the tail is pointing in this direction. It's pointing away from the negative numbers over here. It's pointing towards the really highly positive numbers over here. So once again, the mode is the highest point. That's always easy to find. The mean is always the furthest away from the mode. And then, the median is in the middle right here. So a couple of key points to remember on these measures of central tendency. If the distribution is equal, if it's normally distributed, then the mean mode and median are all equal to one another. Remember that the mode is always at the peak and then in skewed data sets. Remember that the mean is furthest away from the mode toward the tail, and the median is in the middle, and then a final point. And something that's very high yield to know for your exams is that the mode is the least likely to be affected by outliers. When you add an outlier, it means you add one measurement that's very far away from all the others. This will have a slight effect on the mean and the median, but it's only going to affect the mode if it changes the most common number, and it's very unlikely that an outlier is going to change the most common number. That's why it's called an outlier, because it lies out and away from all the other numbers. So it's very unlikely that it's going to affect the mode. So the mode tends to stay in place when you add some unusual measurements to a data set. The mean and median are slightly affected by adding one outlier,